Hello everyone, welcome to my channel. This is Dr. Fan. Calculating the time of a projectile in the air is a very popular question in AP Physics. And today we are going to discuss how to find the time of a projectile in the air. Alright, let's first look at this question. This question says a ball was pushed off two tables with the same velocity. The one off the higher table travels 2 times further horizontally than the one off the lower table. So it asks what is the ratio of their time in the air. So let's see what key information we know from this question. So first of all, both balls has the same velocity. So the velocity here and the velocity here are the same. And the second information we know is the one off the higher table travels 2 times further than the one off the lower table. So this is the horizontal displacement for ball 2, which is delta x2. This is the horizontal displacement for this ball 1, which is delta x1. We know delta x2 equals to 2 times delta x1. So that's the information we know. But we also know for all projectile motion along the horizontal direction, it's a constant velocity motion. In other words, delta x1 equals to Vx times t1, and delta x2 equals to Vx times t2. So now, if we plug delta x1 and delta x2 into this equation, let's see what we can find out. So Vx t2, which is my delta x2, equals to 2 times delta x1, which is Vx times t1. And if we cancel out Vx, what we learned is t2 equals to 2 times t1. In other words, this ball here travels 2 times longer than the ball off the lower table. Alright, so this is the first type of question. Let's look at another type of question. So this question says a ball was pushed off the table along 3 different passes, and it asks which pass takes the longest time before the ball hits the ground. For many students, when they look at this question, they might think ball 3 actually travels the longest time. That's what they think. But the reality is, although ball 3 has the longest range, but we do not know their initial horizontal velocity. If we don't know their horizontal velocity, we cannot use the information from horizontal direction to find out the time. So instead, for this question, we need to look at the vertical motion. So vertically, all 3 different passes have 0 vertical velocity, because once the ball was off the table, they only have horizontal velocity. In other words, for 3 different scenarios, their vertical velocity initially is 0. And if we choose downward as our positive direction, all 3 different passes have the same acceleration, which is g. And for all 3 different passes, they have the same height. Their displacement is h. So for ball 1, 2, 3, they have the same initial velocity, they have the same acceleration, they have the same displacement. Basically, their vertical motion are the same. As a result, their time in the air should be the same. So t1 should equals to t2 should equals to t3. So if this is a multiple choice question, the answer should be they all share the same time. But if we are going to quantitatively solve this, how should we do it? Because we know all this information, we can use one of the kinematic equation. We can use delta y equals to v0y times t plus half gt squared to find out the time. And my displacement is h, my initial velocity is 0, and I only have half gt squared on the right side. So if I simplify this equation, my t equals to root of 2h over g. So in other words, the time is basically determined by the height. And this is a very important relationship between the time and the height. And you can memorize this if you want. Alright, Now let's look at a different version of this type of question. So this question says a ball was pushed off two tables with the same velocity. The one off the higher table stays in the air 2 times longer than the one off the lower table. And the question asks, what is the ratio of the height of the higher table over the height of the lower table? So if we look at this question, the two balls that have the same initial velocity. Okay, that's some information about the horizontal motion, but we do not know their horizontal displacement. In other words, we don't know their range. So let's look at the vertical direction. So we know for both balls, their initial vertical velocity is 0, and we know their acceleration is g if we choose downward as our positive direction. So then delta y, which is their vertical displacement, equals to v0yt plus half gt squared. This is one of the kinematic equation we just used. And we know their displacement is basically their height. So h equals to v0yt plus half gt squared. And we know that for both balls, their initial vertical velocity is 0. So in other words, h equals to half gt squared. And for the ball of the higher table, let's see its height is h2, or you can call it a big H. And this equals to half gt2 squared. And for the one off the lower table, we can call it small h, or h1, which equals to half gt1 squared. So if we want to find the ratio of their height, big H over small h, that equals to half gt2 squared over half gt1 squared, which is basically t2 squared over t1 squared. And we know that the one off the higher table travels 2 times longer than the one off the lower table. So that means t2 equals to 2 times t1. Then this ratio would be 4. In other words, the higher table is 4 times as high as the lower table. So their height ratio is 4. Alright, let's look at another question. So this is a pretty hard question. Many students get this question wrong. So this question says, a ball was kicked in the air along 3 different passes, and it asks which pass takes the longest time before the ball hits the ground. This question is pretty hard because it does not give us any information about the launch angle, about initial velocity, so many of the information is not known. So for this question, many students will choose the option that says not enough information. But in reality, if we look at this question, remember, we know if a ball was dropped off its peak and then hits the ground. If we know this height here, let's see, this height is h. Remember, we have derived this equation already. From the peak to here, the time is basically root of 2h over g. We just derived this equation. And if you rise up from here to the peak and come down from the peak to the ground again, so your total time is basically 2 times of this time. So then basically we know that, let's see, for this ball 1, its time would be t1 equals to 2 times root of 2h1 over g. And for t2, which would be 2 times root of 2h2 over g. And for ball 3, its time in air is 2 times root of 2h3 over g. And we know h1 is larger than h2, larger than h3, because we know the height. Clearly, we can see from the graph. This is h1, this is h2, this is h3. So because t1 corresponding to a larger height, so t1 corresponding to a longer time. In other words, t1 larger than t2, larger than t3. So basically it says this ball stays in the air for the longest time. Alright, Now let's look at another type of question. So this question says a ball is kicked into the air under the same speed at 3 different angles, 40 degree, 55 degree, 60 degree. At what launching angle the ball stays in the air for the longest time? In this question, we do not know the range, and we do not know the height, so it's not very easy for us to solve the time in the air using the previous method we have discussed. But we do know they have the same initial speed, and we know the launching angle. Let's see, this is my initial velocity, which is v. And I know it has a horizontal component. It also has a vertical component. And I know if I have my launching angle, my vertical initial velocity is v0, my initial total velocity, times sine theta. And the angle is given, and the initial speed is given. So basically, I can find out my initial vertical velocity. I also know that at the peak, my vertical velocity is 0. So Vy equals to 0. If I consider going up as my positive direction here, so my acceleration would be minus g. Then if I use this kinematic equation, Vy equals to V0y minus gt, I can find out the time. So let me plug into all the values. So 0 basically equals to V0 sine theta minus gt. So the time in air, the t, equals to V0 sine theta divided by g. So if the initial velocity is the same and acceleration g here is not changing, so the time in air is determined by theta. And we know sine 60 is larger than sine 55 and sine 40, so that means at 60 degree, among these 3 different angles, the ball would stay in the air for the longest time. Alright, now let's summarize all the different methods we have discussed in our today's video. Okay, so the first method is if you know the horizontal displacement and you know the horizontal velocity, you can find out the time very easily. T equals to the horizontal displacement divided by the horizontal velocity. Very straightforward. For the second method, if you know the vertical displacement, so this is your peak, this is the height the ball traveled, or you can consider the vertical displacement. Let's call this is h. So we know the time equals to root of 2h over g. This is when you know the vertical height. And this time is the time from the launching point to the peak. And the third method involves the initial vertical velocity. So if this is your launching velocity v0, we know the vertical velocity, initial vertical velocity is v0 times sine theta. And we know the time from launching all the way to the peak equals to v0 sine theta divided by g. And of course, if you want to find out the time along the whole range, you just times by 2. And that's all the key content I want to discuss today. Hopefully it will help you guys to calculate the time in the air for a projectile. Alright, I'm gonna leave this one question for you guys. So if you have time, you can work on this question. And this question is about the range related to projectile motion. Thank you very much for your attention. I will see you next time.